Welcome back, physics fans, and here we go with our next examples on centripetal force and centripetal acceleration. In number 3, in a local playground, a merry-go-round is turning at 4.5 meters per second. If a 50-kilogram person is standing on the platform's edge, which is 5.8 meters from the center, what force of friction is necessary to keep her from falling off the platform? We are going to have the speed here. So we're going to choose the acceleration. Centripetal acceleration is v squared over r. And therefore, FC is going to be MAC, which is going to be mv squared over r in this case. So this is going to be the frictional force, is the only force that's going to cause her to be pushed into the direction there. Without friction, she would just slide on off. So it's only going to be the frictional force that is applying this force that's necessary, the net force. And that's going to be M, which is 50 kilograms. And the velocity is 4.5 meters per second. That's got to be squared all over the radius, which is 5.8 meters. So applying that all out with Mr. Calculator, we get 50 times 4.5 squared divided by 5.8. And that'll be 174.6. 174.6 newtons. That will be the force that's necessary to push her to make that circle. This is the force that is necessary to cause the net force, which causes the circular motion. We need to have a net force of 174.6, therefore to cause this acceleration, which we didn't calculate, to cause her to go in that circle. Number 4. What is the centripetal force needed to keep a 12-kilogram object revolving with a frequency of 5 hertz in an orbit of 6-meter diameter? So we have, and I know I came up with a third one, but I'm not going to use it. I have 2 acceleration formulas, and they're both on your formula sheet. Look for them. Centripetal acceleration is v squared over r. And if they're not on there, make sure they're on there. And then we get 4 pi squared r over the period squared. We developed them on Friday. Okay? I know there's one with frequency, but I'm not going to keep on manipulating them. T is equal to 1 over the frequency. And if the frequency is 5 hertz, then it's just 1 over 5 hertz. So the period, this formula is on your formula sheet. That's just going to be equal to 1 over 5, which is 0.20 seconds. So it takes 0.2 seconds to do 1 full orbit. So it's going around like stink, really fast. The radius is 3 meters because it's 6-meter diameter. So all the curveballs are coming into this question where I give you the frequency and the diameter. Okay, and so what is the centripetal force? That's going to be MAC, and I don't need to write that down every time. I'm just going to write down M 4 pi squared R over T squared. And that mass is 12 times 4 times pi squared times a radius of 3 all over 0.2. And don't forget to square it. Thank you very much for the encouragement. So plug this all in. We get 12 times 4. And then my calculator, I don't have to hit the times. It doesn't hurt, but I could just put in pi squared, and I don't have to put times in because it knows that's a symbol, and it does that. Then 3 divided by 0.2 squared, and that is going to be a centripetal force of 35,530 newtons. 31 newtons, whatever. Would be probably better off to write 3.55 times 10 to the 4th newtons. Surprise question, part B. What is its speed? What is its speed? Nice cup of coffee. Here we go. V is what we're trying to calculate. So velocity can be calculated by the circumference, 2 pi r, over the time. Okay? And that's just one way to calculate it. There's lots of different ways. We get distance over time, and the distance is the circumference over the time. So 2 pi times 3 all over 0.2. So 6 divided by 0.2 times pi. (94.2 meters per second). Any questions with those two? Thank you very much for the encouragement, but that encouragement also points out what is the most common mistake people do? Forgetting this or forgetting this. Okay. And here's one more question for the next video. A 1,200 kilogram car rounds a curve of 50 meters, radius at a speed of 90 kilometers an hour. We're going to calculate what the centripetal acceleration is and what the centripetal force is. Remember, like, subscribe, smash that like button, comment below. I will reply.